The most ordinary-looking substances on Earth can possess the most extraordinary secrets. Most people think they understand how matter behaves, until you meet the materials that break those rules. Sure, everyone knows diamonds are hard or water freezes at 0 degrees. But there are materials so bizarre they seem to bend the very logic of physics. And no, these aren't your typical chemistry class examples. We're talking about substances that remember their past, metals that melt in your hand, and solids so light they're practically made of air. Quick question before we go on. Which type of material do you think will shock you the most? The one that remembers, the one that melts, or the one that defies gravity? Hold that thought, because your answer might change in 30 seconds. Today, we're diving into the strangest materials science has ever discovered. The kind that sound like they belong in science fiction, but are sitting in laboratories right now, completely real. Absolutely mind-bending. Some of these materials challenge everything we thought we knew about matter itself. Others have properties so useful they're quietly revolutionizing industries without most people even realizing it. Fair warning though, some of these materials are so weird that even seasoned scientists do double takes when they first encounter them. We'll explore each one responsibly, focusing on the fascinating science behind these discoveries and why researchers are so excited about their potential. Let's start with something that looks like magic, but is pure science. Imagine holding a piece of metal, bending it completely out of shape, and then watching it slowly crawl back into its original form like it's alive. That's nitinol, and it's not a visual effect. This nickel-titanium alloy has what scientists call shape memory, meaning it literally remembers its original configuration and returns to that exact shape when heated. Here's where it gets even stranger. You can program nitinol to remember any shape you want by heating it while it's in that position. Once cooled, you can bend it, twist it, or deform it beyond recognition. But the moment you heat it again, it snaps back to its programmed shape with surprising force. Engineers can set this activation point within a single degree Celsius. Medical researchers turned this into something revolutionary. Doctors can insert a compressed nitinol stent into an artery, and once it reaches body temperature, it expands to its programmed shape, opening blood vessels without invasive surgery. The material can bend and flex with every heartbeat for decades, without wearing out or losing memory. But that's just the beginning. Engineers now use nitinol in earthquake-resistant buildings where the metal absorbs massive stress and then returns to its original shape once the shaking stops. Imagine skyscrapers that literally heal themselves after natural disasters. Stay with me. The next material barely even exists, but it's real. Aerogel looks like frozen smoke, and that comparison isn't far from the truth. This translucent material is 99.8% air, making it the lightest solid on the planet. You could balance a brick on a piece of aerogel the size of your palm, and it wouldn't crush it. Despite being almost entirely empty space, aerogel can support thousands of times its own weight. The manufacturing process replaces liquid in a gel with gas, leaving behind an incredibly porous structure. Under a microscope, it looks like a 3D spider web made of glass, with strands separated by nanometer-scale gaps. This architecture gives aerogel thermal insulation properties that seem to defy physics. NASA uses aerogel to capture space dust traveling thousands of miles per hour. When microscopic particles slam into this material, aerogel cushions them so gently they remain intact for study. It's like catching a bullet with cotton candy. If the cotton candy were made of glass and the bullets older than Earth. Architects are now experimenting with aerogel, as super insulation windows filled with this material can be transparent but incredibly energy efficient. A home could remain warm in winter, cool in summer, with walls that let in light but block almost all heat transfer. And now things get even weirder. Picture this. You're holding what appears to be a solid piece of metal, and as you watch, it begins to melt in your palm like ice cream on a summer day. That's gallium, a metallic element that liquefies at just 86 degrees Fahrenheit. Your body temperature alone is enough to turn this solid into a silvery puddle, but gallium's strangeness doesn't stop there. When liquid, you can sculpt it like mercury. But unlike mercury, it's far less hazardous. In controlled laboratory environments, researchers create liquid metal circuits that flow and reshape themselves. Once cooled back to room temperature, these circuits solidify while keeping their new structure. Scientists are developing applications that feel almost cinematic. Liquid metal antennas that change frequency by altering shape. Self-repairing electronics where broken connections flow back together. Soft robots that reshape their bodies for different tasks. Imagine electronics that repair themselves, or robots that squeeze through impossible spaces by temporarily becoming liquid. But what comes next bends something even more fundamental. Light metamaterials aren't discovered. They're engineered, built from tiny repeating units smaller than the wavelength of light. Some exhibit a negative refractive index, meaning they bend light in the opposite direction from every natural substance on Earth. When light hits glass or water, it bends predictably. But when light hits these metamaterials, it bends backward, creating effects that appear to violate physics. Researchers use this to develop invisibility cloaks, routing electromagnetic waves around objects so they disappear from detection. Early versions worked with microwaves. Now scientists have created optical metamaterials that bend visible light backward. Actual prisms exist that bend light the wrong way. Defense applications are obvious, but civilian uses are just as exciting. Lenses that focus light in impossible ways, solar panels that capture sunlight from any angle. But the next discovery doesn't bend light, it bends the rules of electricity. Researchers studying strange metals found behavior that completely breaks our understanding of electricity. At room temperature, they behave like normal metals. But near absolute zero, they enter a quantum state where electrons move in ways that challenge our most successful physics models. In every known metal, resistance follows a t-squared curve. In strange metals, it's perfectly linear. This sounds tiny, but it signals the breakdown of the Fermi liquid theory, a foundational piece of solid-state physics. These materials seem to exist at quantum critical points, perfectly balanced between two phases of matter, frozen at the moment of transformation. Properties emerge that shouldn't be possible. And researchers believe these quantum effects might unlock room temperature superconductors, electricity with zero resistance. That means power lines with no energy loss, computers with no overheating, magnetic levitation without extreme cooling. If this becomes reality, the world will change forever. And now for something small, purple, and scientifically dramatic. This next discovery sounds unbelievable, almost cinematic. Nitrogen triiodide is a compound chemistry professors demonstrate only in extremely tiny, controlled quantities. When dry, the dark purple powder becomes so sensitive that even the slightest vibration can trigger a dramatic puff of iodine vapor and a sharp crack. In controlled demonstrations, it perfectly illustrates unstable molecular bonds. The nitrogen and iodine atoms are barely holding together, and any disturbance provides enough energy to break them apart rapidly, like molecular Jenga, where every piece is already wobbling. Despite its instability, nitrogen triiodide has helped researchers understand molecular decomposition and develop safer industrial materials for fields like mining and construction. From shape-shifting metals that remember their past to materials lighter than air, these substances prove that reality is far stranger than fiction. Science continues to uncover materials that challenge our understanding of matter and open doors to technologies we're only beginning to imagine. Which of these substances shocked you the most? Let me know in the comments, and tell me if you want more deep dives into the strangest corners of science.